where we left off. Remember, we're trying to get this in function form, so we're going to have to solve for y. So, real quick, you're going to have to use some of your log properties, and I know we have said since the beginning of the year that we probably don't know our logarithms as good as we should, and for the record, I'm teaching it much more in depth than I used to because of this now, but they're
all complete.
yeah, they hate them. But if I don't know if you remember this or not. Well, I know you do from pre-cal, but definitely natural log is log base e. And when you're solving something and you're trying to get something from the exponent down to the line, you write log on both sides. Well, if I'm trying to get rid of a log, I do the opposite. So since this is log base e, I'm going to write it with an e on both sides and put these up into the exponent.
Oh my God.
I'm going to write this as 1/5 x to the 5th. It's the same thing. Okay, so now those are in the exponent with a base of e. Now the reason I did that is because there is a log, well, because in order to solve and get rid of logarithms, that's how you have to do it. There is a property of exponentials and logarithms, which remember are inverses of each other, that says this: e to the natural log of x equals x. So e to the natural log of 5 would equal 5. E to the natural log of q would equal q. So in this case, that gets rid of the natural log and makes this on the left-hand side absolute value of y minus 2. On the right-hand side, it's not quite that easy yet, because first thing I have 2 terms up here. So the first thing I'm going to do is, remember, when you are dealing with exponents, if you multiply, what do you do with exponents?
Add.
So that's what's happened here. These are being added, which means that it's e to the 1/5 x to the 5th times e natural log. Now, this is this property. So that fixes that e. So now I have absolute value of y minus 2 equals e to the 1/5 times x to the 5th times 2. Which, just to be in good algebraic order, I'm going to move the 2 in front of the e. Like a because it's a coefficient. Okay, now you have to remember absolute value equation.
There's 2 answers.
There's 2 answers. We split it into 2 problems. The first one looks just like the original with no absolute value signs. Y minus 2 equals 2e to the 1/5. And the other one, you make negative. So y minus 2 equals negative 2. And then I'm going to add 2 to both sides. So I get y equals 2 plus 2e to the 5th, 2 minus 2e. Alright, now, we're not quite finished because we have to figure out which of the 2 would cause this. F of 0 equals 0. So a lot like the one that we did over here, remember our f of 1 had to equal negative 3, so we knew it was the negative square root. Same thing here. We have to figure out which of these 2 causes f of 0 equals 0. Well, it can't be this one, because we would be adding 2 to this piece.
So it's the negative one.
So it's the negative one. Okay, so now on to number 6. Same thing that we were doing, solving this differential equation. I need my y's with my y's and my x's with my x. So I'm going I think the easiest thing to do is first, just swap these places so then you can cross multiply. So I need the x to move upstairs, I need the y minus 1 to move downstairs, and then I can cross multiply. So dy dx, I'm not doing anything to that side yet, equals x to the negative 2, because he got mad when I moved him upstairs. Y minus 1, he got mad when I moved him downstairs. Everybody okay?
Yes.
Alright, so cross multiply. And I now have y minus 1 to the negative 1 dy. X to the negative 2 dx. And now I can sneak that integrand in here. Just to make everybody happy, I'll write this as 1 over y minus 1 dy. Alright, so now I'm actually going to take the antiderivative. So what's the antiderivative of the left-hand side? Natural log of y minus 1. Because it's got a minus, let's put it in absolute values, because we don't want that to go negative. And the antiderivative over here is going to be x to the negative 1 divided by negative 1 plus. For the record, I didn't mention this in class yesterday. I mentioned it when I redid the video and I realized I didn't mention it to you guys. Why do we not put the plus c on the left-hand side? Anybody know?
Because it's like constant and like the left-hand side isn't really part of the formula that we're looking for.
Very good. Because you're getting it. Because you only have to put it on one side. Because it's the constant of the function. So we're putting it on the right-hand side of the rest of the function. If we put it on the left-hand side, we would have to move to the right side anyway, so we're going to put it on the right-hand side. Because the whole goal here is to get y by itself. So we only have to worry about the constant in one place. It's all one function. We'll take care of the constant on the right-hand side. In this case, or with the x is where we'll take care of the constant. It's the constant goes with both. Okay, so now let's plug in. We know that f of 2 equals 0, so alright, there's another log property, I don't know if you remember. Natural log of 1.
E. X. 1. 0. 1.
0. It's 0. Natural log of 1 is 0.
Good job, Liz.
You didn't learn in life.
See,
Guess
it's a
you
half.
will eventually get it.
Alright, so now I'm going back to when I found the function, which is right here. Although I'll write it as negative 1 over x. Alright, is everybody okay so far?
Hold on, I gotta rewrite.
It was so good.
Alright, so now we get to all this, we get to fix this mess, because we gotta get rid of natural logs so that we can get y by itself.
It's whatever x natural log
Do what?
of x.
What'd you say? I'm sorry.
Isn't the 1 over x that natural log of x?
I think she meant to like maybe 1/2.
This is positive 1/2 right
No,
here.
she's talking about the 1 over x.
The
and
1
isn't
over
that a
x.
log?
It would be if we were taking the derivative. But we're not taking the derivative
Okay.
now. Because
Hold
now
on.
we're just
Wait a
trying to get
minute.
rid of this log to get this y by itself.
Okay.
So we gotta do the e thing again, just like we did in the problem before.
Oh,
Make them exponents.
I see. I get now.
We don't have to make the other one. We have
Anything you do
because
on one
we
side,
do
you
one
have to
side.
do to the other side. So you have to.
You get it.
I don't get why.
You gotta
But there's no log.
No, there's not.
Nope.
It's not gonna help us on that side. We're gonna end up with e's on that side. So because there's no log for it to cancel, but remember, since the beginning of algebra in 9th grade, or 8th grade, when you took in 8th grade, anything you do to one side of an equation, you have to do to the other. So because we have to do it to this side, in order to get rid of log, we have to do it to that side. So on the left-hand side, it does in fact get rid of log, and it gives us absolute value of y minus 1. On the right-hand side, we can split it into e to the negative 1/2 times e to the 1/2.
Is there an option
Wait a
to not?
Actually, that doesn't really help us this time.
Yeah, I was gonna ask, is there just an option to not ever do that?
Yeah, we don't have to do it. Well, in this case, it helped us, because this had the natural log, so this would cancel and leave just 2. But over here, it won't help you, so there's no reason to do it.
The way I broke
I
it
am all
down.
about doing it when it helps, but I mean, like in cases where it does not.
It does
would
not,
be
so
wrong.
let's don't. So we're gonna leave this as e to the negative 1/2, 1 over x, sorry, plus 1/2.
Right.
Alright, now, it's an absolute value equation, so we do have to split it into 2 pieces. Y minus 1 equals e to the negative 1/2, 1 over x plus 1/2.
So which one cut off my skin?
1 minus 1 equals negative e to the 1 over x. Okay. Now we have to figure out which one of these it is.
Well, 0 against one.
Well, we have f of 2 has to equal 0. Now, if I plug in a 2 for x right here, I have negative 1/2 plus 1/2. That makes this 0. Anything to the 0 power is 1. But I have y minus 1. So if I add 1 to the 1, it's 2. This is 2. So is it this one?
Yeah, ye.
No.
It has one that's minus
Wait.
It has to be this one.
Oh, okay. My B.
And we can go through the same process.
I had the numbers backwards.
Oh, okay.
Okay, go ahead.
Yeah, that's.
And you know what, you really should. I don't know why I do that, and every time I do it, I irritate myself. I should do the negative one on this side, because that's where negative numbers are, on the left. But I don't. I always do it that way. And then, it's dumb. I shouldn't do that, because it can confuse people. It's negative
Why
numbers.
must you do
So, okay,
that in
so
school?
now, Michelle, an AP question. So, let's try. I'm gonna give you a minute.
Oh no.
I'm gonna give you a minute. You try.
Is that e to the 2y?
E. Oh, that's a good question. What is that?
I'm sure
Yeah,
it is, because that would
that's
make
e
it
to the-
difficult.
I think it's e to the 2. Hold on, let me look.
That's
I think it's
e
e
to
to
the
the 2x. No, it's e to the 2y. You're right.
At least
Good grief,
our
that's
Y's or
terrible.
X's are
Yeah, at least we don't have to flip
where they're
it.
supposed to be.
So, yeah, they are. So no, there's no flipping them over. That keeps you positive at least.
No, I'm already negative, thank you.
Okay, so let me-
I'm gonna get y'all's tests and take them to Mr. G while you're. I'm gonna give you a minute to do that. And I know the recording's rolling, and I'm giving y'all a minute to do this. So then when you get to it, you can fast forward.
Just go ahead and skip the 314.
I can do this.
I'm just gonna have to skip this.
Yeah, we are completely forgot to do this.
Sure, there's some log properties that it isn't there.
Yeah,
There has to
probably.
be, because there's an
Some
e.
that I
Yeah, 'cause
don't
there's
know.
an E. Those are really the only two that you probably didn't remember. I would hope. The rest of them you remember.
Help me,
Finally.
Obi-Wan. You all are my only hope. Have you seen Carrie Fisher's tweet?
No.
Is it the dog one? No.
All of the
El Dodo?
I got it stuff here.
Yeah, I got it down to where it's some sort of function. And then
I thought it would be quicker to Google it. I was wrong.
you can see the thing.
Alright, pull that up for me.
We tweeted it.
I thought I was going to take it.
We weeded it.
Oh,
Oh.
I can't do what you're doing.
I want to. I know not the joke.
Don't you love Carrie Fisher? People have edited the scene where it plays her hologram from like the first they captioned it with that tweet.
That was nice.
No wonder it was weird.
What?
Oh,
Okay, but yes,
I don't know if anyone else is making progress, but I'm.
I started
kinda
talking
am.
about Obi-Wan being my only.
More or less. By a start.
I
don't know.
really love her. She just cracks me up.
Is each of one anything?
Yeah, what is each of the one? Is that
E to the 1 is E. Anything to the 1 power is itself.
so C equals
But there was an E there, Miss Bohannon. Makes it complete.
Well, yeah,
It's an
exactly.
E.
Two. So we're gonna have to go and put like 1/2 into the round, 2 e to the 2y.
I don't know. I'm not gonna think.
yeah, that's I'm at 2e to 2y equals x cubed plus 2e. That's a
What?
I'm stuck after the first step. What do you mean? I didn't know. We've been sitting
I'm just attempting.
I don't know the log base thing, so I can't do this.
I don't
That's literally the only reason why I can't do it.
I don't know what to do
literally
with
said
it.
right here. I don't know what to do.
Do the second part, it's just ignore the first.
So
It's all
I'm
in
gonna-
the that's just like
This is
literally
what I
what
What the?
No.
I think that's where we're supposed to be at.
This is what we have.
Uh-huh.
Rapid fire, how do we take the derivative of e squared y dy?
You have the original, and you take whatever's in the exponent, and then
Yeah,
Yeah.
the
Yeah. Yeah, it doesn't.
We'll do it.
Just write it.
Yeah,
please.
no, that was too quick.
Yeah, you're
and
frozen.
then you take whatever's in the
I'm frozen
exponent,
from
and
here.
then
What's
it's
that?
kind of
But not in the
multiply whatever's in the
Okay.
exponent.
And
So we
we're
cross
writing
multiply. So you all cross multiply, right?
Yeah.
We'll look in a minute and see what you get points for, because
None?
I don't know if you get points for that or not.
Do I get points for this right here?
I don't know, we might, so we'll look and see.
God, I hope so.
E to the 2y dy equals 3x squared dx. Put integrand, did y'all do that?
Yes.
Okay, so see, maybe you did good. Okay, so now, alright. Do you have, because you would have to like chain rule this, right? Because what is the derivative or antiderivative of e to the x power? What's the derivative of e to the x?
X.
E to the x. So what's the antiderivative of e to the x? Right, it's e to the x no matter what. So the derivative of e to the, let's call this u, would be e to the u. But because this is a function up here, I have to have a license to integrate. What would your license to integrate be? A 2. So if it was written like this, 2e to the 2y, you could do it, couldn't you?
Yes.
Right? But you can't. But if I put a 1/2 here, then isn't this the same thing as this?
Yes.
Is that what I'm supposed to write?
Yes.
That was supposed to be.
So I just gave myself a license to integrate. You missed this day. I was going to tell you I'm going to make a video. I didn't video that day, but I'll make a video.
And he looks.
Okay, so because does everybody
I was
agree?
here this day and I'm still lost.
If I do 1/2 times 2, those two things cancel out, and I'm right back here.
Yes.
Okay. So now I gave myself a license to integrate.
So I couldn't have done this problem from the start.
No. I'm just gonna. I'm not doing anything to the right hand side yet, because I don't have to do anything to the right hand side because it's just a polynomial function and I can integrate it normally.
Yeah.
It was just the left hand side that I needed to create a license to integrate. Now that I've done that, I can integrate it. So because I have a 2 here, so I take. Remember, so once you have a license to integrate, what do you do?
I don't know.
You just
Integrate.
integrate the inside piece, which would be, now the 1/2 has to stay there because it's a constant. So it's just e to the 2y.
So I definitely wasn't here for this.
And now I'm going to integrate this side, so I get 3x to the 3 over 3 plus.
Times 2 times 2, that's 2x to the 3.
Now I can plug in what I know. because they gave me f of 0 is a half.
Hold on, wait, can I simplify the 3x over 3?
Oh yeah, I was going to do it all at the same time.
Oh, okay. Of course you were.
So I have 1/2 e to the 2 times a half equals 0 cubed plus c. That means I get 1/2 e equals c.
I almost got it. I got C equals E.
Because you didn't have your license.
You didn't have your license degree. Alright, so now I'm going to plug it back into the function, which is right here. So I have 1/2 e to the 2y equals x cubed plus 1/2 e. Alright, now, I need to get rid of everything that's with y. I need to get y down on the line. What do we use to get things down on the line from out in the exponent?
Log?
ln, logarithms. It doesn't matter what kind of log, but in this case we use ln because
E.
so. And I'm going to write log on the right hand side.
Where do we put that? Yeah, it goes after the, in the waist.
You know what? We should clear the 1/2.
I thought, I wasn't sure
Yeah.
if we could do that first or not.
Yeah, we can and we should. It'll make it easier.
Okay, yeah.
You can do it either way, but it'll make it a whole lot easier. Multiply both sides by 2. Sorry, if you scratch it out. So I end up just with e to the 2y. 2x cubed plus e. That's a whole lot nicer. Okay. Sorry, I didn't notice it before.
Wait, so why can you just multiply by 2 on each side?
To clear the 1/2.
Because it's a half.
Alright, now, the whole point in a logarithm, it's the whole reason they exist, is for exponents to come down on the line in front. That's a log property. So now I have this, 2y natural log e equals all this jazz over here. But, what happens to natural log of e?
It's 1.
It is 1.
Oh,
So it is gone.
I got lucky.
So now, what should I do?
Lucky.
Divide by 2. Now probably they're not going to write it like this. They'll put a 1/2 in front.
Why would you do that?
Now if this, actually this is a free response question, so I think if you wrote it like that you'd be okay. But let me check we'll check the answer guide. You should be, because they're the same thing.
Yeah, I would write it all over too.
There it is, that's our solution.
Yeah, buddy.
Okay, so now it asks us to tell the domain and the range of this function. Think about logarithmic functions. Anybody remember what they look like? Yeah, very good. Okay, so why is this a concern? First of all, range.
It can't be a negative x, yeah? Or
It can't.
actually,
It can't. What's inside the parentheses can't go negative. So we have to fix that in just a minute. And that'll tell us our domain. What about your range though? Because it asks for both. Range of a logarithmic function.
infinite, up and down.
Up and down. It goes negative infinity, positive infinity. So even if you don't know how to do domain, you know what a logarithmic function looks like. It goes forever down and it goes this way, but it's going forever up, just very slowly. So put the range, because I'm sure you get points for that. So we know the range is negative infinity to positive infinity. And then what Willis said is exactly right. The domain is determined by the fact that you cannot take a negative log. There's an asymptote there. So this inside piece that we got, let me write it up here. 'Cause you
0
can't see
to
it.
infinity.
Y equals 1/2 log. This piece cannot go negative. So we have to figure out what would cause that to happen. So you just do 2x cubed plus e has to be greater than 0. It can't equal 0 either. You can't take a log of 0. So I'm just going to solve this. So 2x cubed has to be greater than negative e. Divide by 2. x cubed has to be greater than negative e squared. Take the cube root. So that's it. That is your domain. I am not sure, but I'm going to say, we'll look at the answers in a minute, but I think you need to put it in interval notation. I'm not sure. I need to find that out, because that's a really good question.
Did you just do the square thing to get the cube out?
Yeah, to get rid of the cubed on the x. It's not a, it's a cube root. 3 in the crack. Make
X,
sure.
P, D, 2, O, P, 1, E.
I think it might be faster for me just to look it up on the internet, because what year is this? 2000.
2000. Question number 6.
Oh no.
Oh yeah, you're good, dude. Just go. Just don't break it.
2000. Question.
There you go.
But 2000 has been a good year. I got a lot of questions to do.
2000 was the best year with all the frosted tips going out of style. As a scene phase rolling in. Oh my god.
Yeah, dude. I did. I got it. No. Cross my head.
Hold on, we'll look
You
it up.
notice had frosted tips, a dolphin necklace, a
And it's a
Decepticon wristbands. But he would have been wearing real shoes. So I mean, who's the real winner now?
Did you would have been wearing real shoes?
He had to. He had to.
I broke mine.
I like how they are still
Alcohol
a
oriented.
beverage, no longer Corona, Budweiser now.
It's whatever's around the house. Not the beverage.
Do you like the new flip flops or the old ones?
El Dogo.
Do you like those better than the old ones?
Okay, they're all shoes.
You're wrong, Lois. They're not all shoes.
Yeah, the other shit's just good enough.
Huh?
Willis, I will pay you to start wearing Samurai Jack
Oh my god.
Sims. Do it.
The one with the little
Really?
wings?
Good, not really. I don't care.
We
I
have
feel
to
like
find
you
them.
fall like
We have to
20
make
I
them.
have
No, I
absolutely
want
His
zero
feet will
shit.
literally just be
I
like.
wanted to buy you a dog for Sunday.
Huh?
I wanted to buy you like 69. I can probably raise it.
You
had like all the straps.
And it has no toe coverings in it. It's like it leaves the heel open.
Yeah. Yeah, I can probably make some Samurai Jack shoes in the wood shop here.
Just
like, give me the specs.
Oh, the splinters. Samurai Jack.
I was saying, did you watch
I
it?
was
I'm gonna put it in as a good part.
Oh my god, look. I've done it.
Oh, do you have them?
Oh, the wood. It's like how to make Samurai Jack shoes.
Okay, what is it?
Like out of straight wood.
They are.
That's what they are.
Splitters in his feet all day.
Nah, you just gotta
You
say
have to
that.
sand it down. and then-
Yeah, you divide by 5.
Sand
No, I want
doth
you to
flow.
leave.
This is, yeah, divide by 5. You're gonna get the logarithm by itself. Divide by 5 and then
Yes.
divide exponentially.
I remember that episode, like his sandals broke or they sold him. He used a whole bunch of different sandals for that episode.
Did it
I
again?
remember the fishbowl one, where he jumped down and they shattered. He had to like tiptoe over.
Then
Like
I can still find you some things.
I remember that. That was great. I miss all the good cartoons.
Yeah.
I tried to watch the. I do. I still have time.
Oh, it
Is it
sucks.
bad?
But
It sucks.
I need to have a revamp of like an old cartoon that almost always turns out bad.
Yeah, she's not good anymore.
what are we talking
How
about?
are we gonna get through the Powerpuff Girls without the mayor
They
and
still do
the
that.
secretary?
They still have no good
And they still go bears. They still go bears.
Do they still have
Buttercup's
the,
voice is
transgender
super
just
different.
cussing devil?
Really?
I got
Yeah.
one.
Okay, here it is.
Sounds
Let's
like a
see
jam.
let's see what we get. Points.
Zero.
I love
I have a little bubble thing.
But it's
I
like,
was-
Okay, so here it is. Hey, you do get a point for separating your variable.
Dude,
Yay!
you feel like 6 points.
So all you have to do
Oh
is
my
this.
God.
Separate the variables
I
and you
would
get it.
have got a point.
Then you get a point. Okay, here's another good thing. If you do the just the dx side, you get a point. And that one was just straight up any derivative.
It's super
So,
So-
even if you didn't get the left-hand side, so Annie, you'd have gotten the right-hand side, because you missed the left-hand side by the half, but you got the left side. You get a point for adding the constant. No, that's the constant integration, the half.
I'm just pulling up the subspace.
Okay, so here's your, using your initial condition. If you plugged in your 0, you got a point for that. Solving for y. No, 0,
What?
1 if y is not a logarithmic function.
I plugged in that, I used that stuff, I just didn't use it right.
Oh, it's saying if they didn't put
If you didn't put the natural log.
yeah, if you didn't put the natural log.
But if you, you'd have gotten the point for, I think you get the point for plugging in, even if your equation is wrong.
So
Because you've proven to them that you know the steps and you know what to do. Just because you messed the equation up in the beginning, they don't penalize you for
I
not.
really don't like the
But if there's no
idea
constant
of
integration,
these.
you can only get 3 of
It's
them.
just like
And
even
if you
if
don't
know
have a
you're
variable,
gonna
you
get
can't get any.
do whatever you can.
Well, good thing we got
Or
that
maybe.
first.
Okay, so did y'all see that? Y'all, put this on away.
You missed my quote.
If you don't put the constant of integration, the 1/2, you can only get the first 3 points. Until the 1/2 determines whether or not you can get the bottom 3 points. If you didn't separate the variables at the beginning, you don't get any other points. So even
make
if
sure
somewhere
to
along the
separate.
line you plugged in and stuff, you still don't get the points because you had to separate. But we all separated, so we got those. Okay, so then let's look at the bottom half.
So if you solve the whole thing, but you didn't do that first step.
Then you're, nope. You probably wouldn't have solved it correctly. Okay, so then there's your domain. You get a point for knowing that it has to be greater than 0. So you get a point just for setting it up, even if you didn't solve it correctly. You get the point for setting it up. You get a point for the domain, note.
Oh, you
Zero's
can
not
just-
in the domain. Okay. Okay, so it doesn't matter how you write it. They wrote theirs in algebraic notation.
Wait a second, but I didn't put 0 in my domain.
Yeah, you did.
Right.
Oh, wait.
We solved it. You went and you put it like that and you solved it out. Remember?
Well, I mean, technically, we wrote it.
No, 0 is not in the domain. But 0 is not in the domain. I don't understand what they're saying.
Well, because
I
they
think
have
there's-
2x to the cube plus e is greater than 0.
Yeah, that's what they do.
Yeah.
So do you think that that's what they're saying? If we did this, we're okay?
Yeah.
Yes.
I think it's saying that 0 is not in the domain, like it's not included.
Not included. Right. I agree. Okay, and then there's the range. So you get a point for range. And y'all all do the ranges. When I said, do you remember what a logarithmic function looks like? You all did this. So you do know what it looks like. So you could have thought, okay, I know what the range is. The problem is where was that vertical asymptote? So, okay. Okay, there's another question on the back. Oh.
So we said this with me also.
This is just one reason I hate myself.
All right. So the acceleration of a particle moving along the x-axis at time t is given by acceleration
We
of
changed
t equals
gears.
6t minus 2. No, we didn't. If the velocity, we didn't.
Derivative, okay.
Aha. If the
Yeah.
velocity is 25 when t equals 3 and the position is 10 when t equals 1, then the position x of t equals, so they're giving position as the x function, by the way. So, how does it go? What comes first?
Velocity and then acceleration.
Position.
Right, it goes
Velocity,
position, velocity, and acceleration. They gave me acceleration. So if I need the other functions, what am I going to have to do?
Antiderivative.
Take the antiderivative.
Antiderivative.
So what are they specifically asked? Position. All right, so I've got to take the antiderivative.
Twice.
I know velocity.
We go.
I know
Velocity.
velocity is going to equal the antiderivative of 6t minus 2 dt. That I can take easily. So my velocity, I'm going to write v of t again, equals 6t squared divided by 2 minus 2t, which is 3t squared minus 2t plus c. Alright, that's velocity. They gave me something at velocity, didn't they? If the velocity is 25 when t is 3. So I know v of 3 equals 25. So I can plug in and find my constant. That's why they gave us that. So 3 times 3 squared minus 2 times 3 needs to equal, plus c needs to equal 25.
It was a bad song.
Bless you.
Thank you.
Oh, I have a 3 here, that's not squared. So 27 minus 6. 21 plus c equals 25. So c equals 4?
Yes.
Alright. So now I know what my v of t function is. It is 3t squared minus 2t plus 4. So now,
Now we gotta take the
and
integrator.
because I'm looking for what they're calling x of t, which I would probably call p of t, but okay.
It's C. I think I got the spooky.
No, Haley, no more. It's C.
Right. I don't have it
It's
worked all the way out yet. The answer's C.
Yeah.
Oh yeah, it has to be C. We don't even have to do the rest of it.
See, I would have
It
messed
has
up
to be C.
and chose B right before we started the. I
Oh,
would be like, I said.
yeah, exactly. Instead of going one more step.
Yeah.
Yeah. Yeah, that's probably the
Womp womp womp. Womp womp.
Mrs. Bohannon?
Yes.
I can honestly say that I wouldn't have been able to do that problem without that.
I think you could have too.
I could
Me
have
too.
done
I mean,
that.
I could, oh my god.
Yeah, but we
Huh.
See? Oh, that
Miguel
recording's
did
still
it.
going.
I don't know what I'm doing.